Okay, so I hope everybody is enjoying their vacation. No, just kidding. I know it's not a vacation, but anyway. This is the video that um, I I said I would make with that sampling distribution demonstration. So it's from Online Statbook, as you can see. This this resource has all kinds of good stuff on it. And by the way, if you don't understand what I'm saying in my videos, I haven't heard any complaints yet, but there's plenty of stuff online that you can supplement it with. Don't forget. So, but anyway, like this, like videos, all kinds of stuff. So remember, all this stuff is sort of it's standard across the board. Everybody takes this same course, more or less. Okay. So, and not just at Dalton, I mean everywhere. So, all right. So, let's look at this example really quickly. So, what are we looking at here? Um, So here we have a normal distribution, don't we? And again, this is flashing back to chapter 8, isn't it? We've already moved on to chapter 9, but this is chapter 8 stuff. This is a short video. This will explain what we were talking about though. All right, so we have a normal distribution right here. Ignore this stuff for a second. We just have a normal distribution, don't we? We have the mean of 16, a median of 16. Those are the same, right? Normal distribution. Standard deviation of 5. This red line uh, delineates our standard deviation. No skew, no kurtosis. About as normal of a distribution as you can get. Okay, so what we're going to do now is we're going to perform the sampling distribution of sample mean in model form. Okay, so what we're going to do is we're going to pull from here, and whatever sample size we pick, we're going to pull them down from here. We're going to average them. They're going to drop right in here. Okay, so in this case, we're going to pull 5. Okay, or 5. Okay, and we're going to average them, and then it's going to plot the average right here. All right, so let's give this a try. Where's the thing at? Am I blocking it with this video? Oh no, you just got to hit animate. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Averages it, and boom, plots it there. So that's the average of these 5, isn't it? Okay, let's do it again. 1, 2, 3, 4, 5. Okay, and what does it do? It takes those 1, 2, 3, 4, 5, and it averages them. All right, let's do it again. 1, 2, 3, 4, 5, average. Okay, is everybody getting the hang of this? Now, with only these 3, let me ask you something. Given what we've been studying, what is this curve going to look like? Or what is this going to look like when we take every single iteration of these, every single possible combination of 5, and average them right through here? What is it going to look like? I don't know why that mouse is flashing like that, but what is it going to look like? Well, let's keep going. And if you don't know, then it's going to become obvious pretty soon. But let's look over here too. Keep an eye on this. We've been 3 times, repetitions 3, mean 0, median 14. Okay, but watch, keep an eye on this and see if it ever, think about it just for a second, what you think this stuff is going to do. This is just a reflection. This is just the numbers of this. Okay, so let's take a sample size bigger. Let's go all the way up to 25. Remember, that would be a good number for the less normal our underlying distribution, the more the higher the sample size we have to take. Now this, our sampling distribution, our sample mean, i.e. the central limit theorem, is going to work with a really small sample size, even all the way down to 2. And why is that? Because the underlying distribution is normal. Okay. All right, so now we have a sample size of 25, so we can animate it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Boom, average them and plot it right down the middle, just about. So again, when we take a sample from the population, there's going to be an error, isn't there? So there's a little bit of error, sampling error, which is what? Well, here's our mean, 16, right, for the overall population. Well, we're down here at, it's close to 16, but 15 and a half, right? So what would our error be? If it were 15.5, the average, it would be 0.5, wouldn't it? The error, 15.5 to 16, the sampling error. Okay, let's do 5 of them now. So this is going to do 25, 5 different times. Boom, and instead of dropping them all down, 125 times, 5 times 25, it just populates it for you instantly. But now we got enough information to really have a meaningful mean, median, all that. So let's look at this. Let's compare these numbers to this. So reps, we've been 6 times, because remember we did once, and then we just did 5. Okay. Remember we did animated, that means 1, and then we did 5 of them. Okay. That just popped up. So remember our underlying distribution has a mean of 16, median of 16, and a standard deviation of 5. Well, what are we looking at right here? With 6 repetitions, we have a mean of 13.35. So our standard, our sampling error would be what? It would be what? 2.75, wouldn't it? Or 2.75. Yeah. Okay. 2.65. 2.65 because 13.35 plus 2.65 is 16. Okay, our median is right on, isn't it? 16. So our median's already there. Our standard deviation is a little wider, isn't it? But remember what we would expect in the end for this standard deviation. It's going to be a little bit smaller, isn't it? Okay. All right, so now let's go ahead and do it 5 more times and watch what happens. 1, 2, 3, 4, 5. Again, a sample size of 25. Yeah. And now we're a little bit closer to the mean, aren't we? And our median's still right on. Our standard deviation's a little bit tighter now, isn't it? Okay. Now let's do this sucker 10,000 times. Remember, animated means you just drop it down once and it animates it. 5 means we do it 5 times. 10,000 times. Remember, these combinations get big because there's all kinds of variables in here that we can do different combinations of, okay? So 10,000 and boom. What are we looking at here? Okay. So the question I asked you, what is this going to look like? Well, this is a little more probably what you were thinking, isn't it? Because it's starting to take on a really normal shape, isn't it? But what else about it? It is a normal shape, and again, look here. This is 10,011 reps. This is a mean of 16, a median of 16. So our median are right on after 10,000 tries, which makes sense. What's our standard deviation right here? 1.02. See that red line? Again, that's our standard deviation versus this standard deviation. Really skinny, huh? Look at the whole size of this distribution. Really skinny, huh? So that's what we said would happen, isn't it? These things become what? Taller and thinner. So what's our it's skewed a little bit, but what's our kurtosis? 0.31. So it's a little bit taller than this thing, isn't it? So it's a little bit taller than the underlying population distribution, and it's also what? Skinnier, isn't it? So now let's do it 100,000 times. And let's see what we got. Well, it changed it a little bit. Now our mean and our median didn't change. They're already there where they need to be. Standard deviation is 5. Now our standard deviation here is 1, and our kurtosis is shot up. It's still a tiny, tiny bit skewed, but it's gotten even taller, hasn't it? Okay? So, but our mean and our median are the same, which, again, that's what we expected to happen, isn't it? Because we said that when we take all these different combinations of samples from the underlying population distribution, we're going to get a taller and skinnier sampling distribution. Now, until we use what? Every single possible one of these combinations here, and then we're going to get our final data over here. But let me show you this right quick. So remember the beauty of this. So this is a normal distribution, isn't it? But remember the real beauty of the central limit theorem. We can turn any distribution we have into a normal distribution, can't we? Okay, so let's take this distribution right here. Nothing normal about that is, well, kind of, nothing normal about this sucker is there at all. Okay, that looks more like a city skyline than a data distribution. All right, so let's clear the lower three. And with this distribution, let's go ahead and do the same thing again. Let's animate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, a sample size of 25. And boom, averages and plots it. Now, let's go ahead and do 5. And let's do 5 more. And 5 more. So we got 16 reps. 5, 10, 15 plus the original one we did. What's our mean? 14.4. What's our median? 15. So we're getting a little bit closer to this data, aren't we? Oh, by the way, every distribution has a mean and a median, mean and standard deviation, don't they? Remember? Okay, so it doesn't have to be a normal distribution. But now let's jack this one up to 10,000, 10,000, 10,000, 10,000, 10,000, 10,000, 10,000, 10,000, 10,000. That's 10,000 times. Each one of those is, we took 25, averaged them, and plotted it. 10,000 times for each time I hit that. Okay, so now we're up to 100,016 reps because I hit 10,000 10 times, didn't I? Our mean is 15.61, getting pretty close to this mean up here, isn't it? And our standard deviation's 1.61, way sucked in from the standard deviation of this distribution up here. But what did we do? What's the real gist of it? The real power of it? Let's do it 100,000 times more. And 100,000 times more. And now we've done it. I'm going to do it 10 times, a million, over a million times. And a million different combinations. And what's happened here? We've turned this big, nasty distribution into a normal distribution, haven't we? We can use our tools that we can use on normal distributions on this, can't we? On this data distribution, we've suddenly turned it into this, haven't we? This is highly usable. This isn't. We can't do anything with this. We can do some series calculus with this, all kinds of curves and blah, blah, blah. Or we can use our continuous data tools on this, okay? All right, so I just wanted to show you that. It's just an illustration of what we've been talking about. And yeah, hopefully that really drives it home. Sorry to be so late on this video. I was having a little trouble with all of my video and recording equipment, but it's all good now. And please let me know if you have any questions. I sent out a schedule last night with our schedule going forward. Oh, and remember, please remember, everybody, for Georgia View's purposes, is in Section 1 now. So I guess you won't be seeing this unless you've caught on to that. But everybody is in Section 01 now. That new card, if you're not in Section 01 that you saw pop up, that keeps me from having to post everything 3 times. Okay, this doesn't affect your grade, your connect, anything else. It's just where you get your messages, okay? All right, so, and you should still have access to your old one too if you need to look back at the syllabus or anything like that. But all messages are going into Section 1. Okay, so I hope everything's going well. I've tried to keep this as simple and easy going as we can because I know a lot of teachers are probably freaking out on you and you got a lot to keep up with now, a lot of online systems and a lot of online new stuff. I'm trying to keep this as easy as we can. Keep using Georgia View. Just watch the video and do the work like you would normally. If you have any questions, just email me. A few of you already have. I've tried to respond to as many as, well, I think I've responded to all of them. But anyway, if I haven't, I've answered the question through the system or whatever else. So, but yeah, let me know if you have any questions. And just keep on doing your best, and just please stay safe. And yeah, we'll see you in the fall. All right. Have a good day, everybody.